What is static electricity? Observe these visuals. What is this due to? This kind of electric shock is due to static electricity. Let's explore static electricity. Static electricity was first observed by a Greek philosopher called Thales. Thales observed that a piece of amber, when rubbed with a piece of wool, attracted feathers and splinters of wood. Later, Dr. William Gilbert, a physician, showed that besides amber, other substances such as sulfur, glass, and diamond also attracted small objects. He also observed that presence of moisture hampered the production of electric charge. William Gilbert used the term electricity to describe this mysterious power to attract materials. What exactly is happening when two materials are rubbed together? When two materials are rubbed together, electrons from one material are knocked out and are transferred to the other. The material that loses electrons gets a positive charge, and one that gains electrons acquires a negative charge. This method of charging bodies by rubbing them together is known as charging by friction. Materials charged this way attract other small objects. Let's see how we get static shocks. Walking across a carpet can charge our body. As our shoes rub against the fibers, they pick up electrons. These electrons move through our body, and our body acquires negative charge. This negative charge remains in our body until we touch something metallic, like a doorknob, which conducts electric charges. The extra electrons are attracted by the protons in the doorknob. The electrons jump from our hand to the doorknob, giving an electric shock. This loss of static charges is called static discharge. Rubbing produces an electrostatic charge, and the bodies are said to be electrified. These electrostatic charges are static and do not flow through wires like the electricity produced by a battery. Static electricity can be generated only in insulators like plastic, glass, rubber, fur, paper, and so on.
Yes, what have you got from all this, whatever we have seen?
That by rubbing electrons are transferred and we get charges, and then those electrons again get attracted towards the positive electrons, like metals.
That's not a very clear picture what you are telling. We have understood some part of it.
So it's basically like whatever loss of charges there now, that becomes positive, and whatever is the gain of electrons becomes positive.
No, gain of electrons will become negative because electrons are negatively charged.
Oh yes.
Basically, you see, suppose you are having, suppose this is some kind of a rod, like a glass rod or a plastic rod is there, and here you are having a cloth, a silk or a wool cloth on which you are rubbing this rod. Okay. So basically what is happening is, suppose here the electrons are getting transferred. The electrons are getting transferred from one object, say object A to object B. Now if we draw the structure of an atom, basically this atom is going to consider the center part of the atom. What is the center part of the atom called?
Nucleus.
It's called nucleus.
Yeah.
Inside this nucleus, what kind of particles are present?
Protons, neutrons, and electrons.
Everything is there inside the nucleus.
No. Proton and neutron.
Protons are positively charged.
Neutrons have no charges.
Neutrons have no charges, so I'm writing 0 for this, and electrons are placed in different orbit. This is the basic structure of an atom. Initially, if you see the number of protons, that is the number of positive charges, will be equal to the number of electrons, which is equal to the number of negative charges.
Yes.
So initially, when you are considering these atoms of insulators, what are insulators? Insulators are basically poor conductors of electricity. All non-metals will be insulators, and materials like rubber, plastic, wood, all these are going to be insulators. They will not allow the passage of electric current through them. So in such kind of materials, okay, these materials, the static charges, it is possible to develop static electricity charges or static charges, and they will obviously will not be able to flow like current electricity, as it has been explained in the earlier part of the module. Now here, this is the basic structure of an atom. Okay, I am considering copying it. This is another material. Suppose this is your material A and this is your material B. Now when you are rubbing this, okay, when this material A is rubbed with material B, say for example, okay, in material A, in this material, that is material A, the ability to attract these electrons is lesser. While in case of this material B, the ability to attract these electrons is greater. So what is basically happening is these electrons are getting transferred from material A to material B. Now when these electrons are getting transferred, so obviously the number of electrons in material A, there will be shortage of electrons. So the number of protons are going to be more. While in case here more electrons are present over here, you know, electrons are negatively charged. Because here number of protons are greater, number of protons are more, that is positive charges are more. So this material which is losing electron, it is going to become positively charged. While this material B, which has gained electrons, there are more number of negative charges. So that object is going to get or acquire a negative charge. This method is known as charging by friction. This method of charging is known as charging by friction. Basically, both the objects should come in contact with each other and they should be rubbed with each other. So this is the first method of charging a body. Of course, it is only in case of insulators, that is charging by friction. So the same thing is happening over here. Suppose this is a rod A, this is an object B, say for example any kind of cloth, silk cloth or wool cloth. Okay, you are rubbing both of these objects. Then what is happening is from object A, the electrons are getting transferred to object B. Because object A is losing electrons, so it is going to acquire positive charge because more number of protons are present. And here obviously here more number of electrons are present, therefore object B is going to acquire a negative charge. Also one should remember that say how much ever the charge is acquired by object A. Say for example here 100 electrons are transferred. So it means here 100 protons are going to be more. So this is going to have the charge of 100 plus. Why? Because 100 protons are more over here. Here 100 electrons are transferred in object B. So therefore 100 electrons are more than protons. So the charge that is present on object B is 100 negative. What I mean to say is how much ever the charge is acquired by object A, same amount of charge is acquired by object B, but the sign is opposite. If one is positive, then the other one is going to be negative. I just want you to copy down both of these diagrams. If you have any questions, you can ask me.
So, like the same number of electrons will only get transferred now, only the charges will be different.
Yes, the charges will be opposite in sign.
Yes.
Because here these many electrons are lost, so that many more number of protons will be there.
Okay.
So that will have positive charge, and same way that many number of electrons are transferred on the other objects, so it will have same amount of charge, but it will be negative because electrons are negative in charge.
Yes.
Okay, we'll just write down the names of these materials. Static electricity can be generated only in insulators like plastic, glass, rubber, or paper, wool. Basically, static electricity cannot be generated in good conductors of electricity like metals like copper, silver, and so on.
Observe the demonstrations to understand the nature of electrostatic charges and their interactions. Electrify two plastic rods by rubbing with the same piece of fur. Bring the charged rods close to each other as shown. They repel each other. Again, charge the plastic rods with fur. Bring one of the rods near the fur. The rod attracts the fur. Now bring the other rod near bits of paper. We see that the paper bits are attracted towards the plastic rod. Electrify two glass rods by rubbing with the same piece of silk. Bring the charged rods close to each other as shown. They repel each other. Again, charge the glass rods with silk. Bring one of the rods near the silk. The rod attracts the silk. Now bring the other rod near bits of paper. We see that the paper bits are attracted towards the glass rod. These experiments show that there are two kinds of electric charges. The kind on the plastic rod rubbed with fur and the kind on the glass rod rubbed with silk. The charge produced on plastic rod when rubbed with fur was called negative, and that produced on a glass rod when rubbed with silk was called positive.
Okay, this is a plastic rod. It means it is carrying a negative charge.
Yeah.
This is another plastic rod which is also carrying a negative charge. It means more number of electrons are there.
Mm-hmm.
And if both the same kind of charges are there, negative, negative, then they are going to repel each other.
Oh, yes.
This fur and bits of paper, they are uncharged object. They are not carrying any charge.
Oh, okay.
Here, the glass rod which is there, it is carrying positive charge. It means it is lost electrons.
Yes.
Because more number of protons are there. And you can see here the positive and positive charges, both of them are repelling each other.
Hmm.
So if the charge is negative and negative, they will repel each other.
Repel.
If charge is
Positive.
positive and positive, they will repel each other.
Repel. Hmm.
When the charges are of same kind, we call them like charges. When
And
the
so
charges,
in the third picture, then why are they attracting the other objects?
because this is the basic rule of static electricity. If you are having a charged object,
Then it will attract uncharged objects.
uncharged object also.
Okay.
Okay,
Yes.
this is the basic thing that you are supposed to understand.
The concept of positive and negative charges was introduced by Benjamin Franklin. There are two kinds of charges, namely positive and negative charges. A charged body attracts an uncharged body. Like charges repel each other, and unlike charges attract each other. Electrostatic charging. What is electrostatic charging? Electrostatic charging is the process by which a material gets electrified by the transfer of static charges. Static charges can be produced by three ways. They are charging by friction, charging by conduction or contact, charging by induction. In this method, electric charges are produced by rubbing different materials together. When you rub one material with another, electrons have a tendency to be transferred from one material to the other. For example, rubbing glass with plastic wrap generally leaves the glass with a positive charge. Rubbing PVC rod with fur generally gives the rod a negative charge. This method is useful for charging insulators. The other. For example, rubbing glass with plastic wrap generally leaves the glass with a positive charge. Rubbing PVC rod with fur generally gives the rod a negative charge. This method is useful for charging insulators. Charging by conduction means that the two objects come into actual physical contact with each other. Charge will be transferred from the object to the conductor. The conductor acquires the same charge as the charge on the object. Let's assume we have a negatively charged metal rod and a metal sphere AB supported on an insulating stand. Bring the rod close to the sphere. The metal sphere is a neutral object. Observe the separation of charge happening in the neutral object as negative electrons are repelled to the side opposite to the rod. Note that the rod and the sphere are not touching and no charges have been transferred. Now, allow the two objects to touch. Some of the negative charge will get transferred to the uncharged metal sphere. These electrons neutralize the positive charges on the left-hand side of the sphere. Due to the transfer of electrons, the rod loses some of its free electrons and becomes less negatively charged. This transfer continues until both the rod and the side A have the same amount of negative charge. When the rod is moved away, the metal sphere has an excess of electrons and hence negative charge.
You must have observed that in charging by conduction, you are actually touching both the objects, and the charged body which is there, it is losing some of its own charge.
Yes,
This is happening in case of conduction. If the object is positively charged, if we touch the object, then the uncharged object is going to acquire the positive charge. In this example that we have seen, the last one, we had brought the negative charge near it. So you can see the sphere is also, the uncharged object is also acquiring the same type of charge, which is negative charge. This method of charging is known as charging by conduction. There is another method, third method also, which is charging by induction, which we are going to see it in the next part.
Have the same amount of negative charge. When the rod is moved away, the metal sphere has an excess of electrons and hence negative charge. Displayed here are the steps involved in charging a conductor positive by conduction. Induction is the process by which a body acquires a charge of opposite sign without losing any of its own charges when another charged body is brought very close to it. Let us try to make a metal sphere AB positively charged by bringing a negatively charged glass rod near it. The metal sphere, which is supported on an insulating stand, is initially neutral. Bring a negatively charged rod near it without touching the sphere. The free electrons in the metal sphere are repelled by the excess of electrons on the rod, and they shift away from the rod. The charges cannot escape from the sphere because the supporting stand and the surrounding air are insulators. Thus, we see that there is excess of negative charge on the side away from the rod and deficit of electrons on the side nearer to the rod. These charges are called induced charges. Now, earth the side B of the metal sphere with the help of a conducting wire. The negative charges, that is, the electrons, flow to the ground, but the positive charges at the side A remain due to the influence of the charged rod. Now, disconnect the sphere from the ground. The positive charge continues to remain on the sphere. Remove the rod. The charges spread uniformly over the sphere. Thus, we get a positively charged metal sphere.
So in the first step, what we have done, we have brought the negative charge. This is your first step. In the next step, because this negative rod is brought over here, it will repel the electron. So the electron is going to come on this side, on the right hand side. And on the left side, we are going to have positive charges. You can see here there are positive charges, the red marks. These charges that are forcibly developed, we call them induced charges. Then in the next step, what we are doing is we are attaching a wire to grounding, which is called as earthing. It is also called grounding or earthing. A grounding is such a wire or any such material which is going to remove the charges. So what it is doing here, because on the right hand side, this is your right side. Here more number of electrons are there. So these electrons will go down over here because of earthing. Right? Because here there are more number of electrons on this side. Look at this part, the one that I'm marking, the red part. Here more number of electrons are there because of grounding or earthing. These electrons will go away. Earthing will remove any kind of charge, whether it is positive or it is negative. So over here, because of this earthing, now you see the fourth step. Fourth step is over here. You can see from this side, all the charges, the negative charges, the blue charges, the blue part which is there, that have got removed. Now in the fifth step, what you are doing, you are removing the earthing. This earthing wire which is there, that is removed. And then finally, what you are going to do is the rod is removed. When the rod is removed, the positive charge which is acquired on the sphere, it is going to spread uniformly on the sphere. There are two important points over here when you are doing charging by induction. The first thing is that you are not actually touching both the objects. The second point over here is whatever the charged object you are bringing over here a negative charge. So ultimately this object is acquiring the opposite charge, which is the positive charge. Another very important point over here in charging by conduction is that the original rod which is there, which is negatively charged, it is not losing any of its own charges. This was not the case in case of conduction. In conduction, you are actually touching both the objects. Okay, you are having say a negative rod is there. You are touching it to the uncharged objects. These electrons will get transferred. This will become negative and this will become less negative. So the original object which is there, it's losing some of its own charges. This is all the diagrams that you are going to draw stepwise 1, 2, 3, 4, 5, 6 that I have sent. And also you are going to note down the differences in charging by conduction and charging by induction. You can see the important points over here. In charging by conduction, the charging body touches the uncharged body, while in case of charging by induction, charging body is brought near the uncharged body, so it is not touching it. Then charge of the same type is produced in case of conduction. Here the charge of opposite type is produced in case of induction. Then some charge of the charging body is lost to the uncharged body. That is in case of conduction. And in case of induction, no charge of the charging body is lost. These are the differences that you are going to note down between charging by conduction and charging by induction. And also you are going to take down all of these diagrams. If you have any questions, after copying it down, you can ask me. Okay, your question is, why is earthing done? If earthing is not done, then these charges in, you can see step number 2, they are going to remain like that only.
Okay.
If you remove this negative rod, then again it is going to become original step 1, uncharged sphere.
Yes.
In order to remove the negative charge from right hand side, therefore this earthing is done.
Yes, sir.
Now this is how we have charged the sphere positive by bringing a negative rod. After you copy everything, I want you to draw the same diagrams when you want to charge this sphere negative. This is what step number 1 to 6 diagrams you are going to do on your own, and you are going to send it to me and I will check.
Yes, sir.